Good morning and assalamu alaikum to all my fellows, teachers, dear friends. First of all, I would like to sincerely thanks to Rifa International University for giving me such an excellent and wonderful opportunity to present today. I'm truly grateful for this platform that allows us to share the knowledge and explore new ideas in the field of the technology and the healthcare. Today, I'm gonna represent something about AI, and I would have to represent how the building trust in AI, explainability as a pillar of the future digital healthcare. It's a main AI is one of the thing everyone knows, and if we can have to follow up, we can have to have a wider vision, wider implication, and the wider expanded version of healthcare we can find. It doesn't mean we are going to replace the doctors, but we can have to help the doctors to go for with the help of the AI innovative approaches, and we can do very well in that. Okay, there is a question why we have to trust and the it matters in the healthcare AI, right? If you we can see in a daily basis or in a routine, we have to diagnose different kind of the diseases, and human being is actually the main part of this world. And when they are existing here, along with them, there are some health issues as well. That's why AI can help us to increase, to diagnose, detect, and monitor. And while monitoring, we are going to help them how to work on the particular kind of disease, right? And if we can have to introduce a system that is a black box. And what black box is, they are giving the answer, but they are not showing how they have to reach up to that point. And from that particular testing and the answer, we can come to know what is going on. And doctors must have to justify the decision on the basis what we have to do with the patient and what the regulatory things we can have to do. Okay, someone's audio is there. If you can have to unmute yourself, I would be requested. I think so. That is Samir, because it's distracting. Thank you very much. I think so. It's not anymore. Okay. It's mean the doctors can have to go for the decision with respect of the AI things. And this way, when they have to follow up the decision on the basis of the AI, it can have to be the safe adoption. And they can have to create some trustworthy AI into the healthcare as well. Right. Now, I told you if we can have to work on black box. Now, from AI, I have introduced the black box. Now, another concept, which is really very innovative, very few people, but still they are working on the glass box as well. Black box is giving the answer without knowing how we have to implement it, everything. On the other side, the glass box is going to give us the logical vision, which is going to reveal some model and their reasoning parts. And this way, we can have our mysterious machine into our accountable partner. It's mean versus these two can have to give us maximize accuracy for the particular data set. Explainable AI. From AI, we have to move on to the explainable AI. That techniques can make some models to have some decision, and which decisions are really understandable by the doctors, by the human beings as well. And we are going to have the transparency and interpretability by using different models like the post hoc, and with the post hoc agnostic methods and model specific. These are the particular kind of the explainable AI methods, which is going to use to improve the transparency, interpretability. And because of that, what is the target we are going to get, what is the decision we are going to have. The doctors can detect the patient's particular disease, they can have to manage that and regulate in the future. That's why we have to check with respect to the explainable AI, transparency, stability, and the clinical relevance in that particular field and particular disease as well. XAI techniques further into the healthcare, different kind of. Most probably we are using the SHAP and Lime, and in a lot of my papers I have been used that, and they can have to give us the medical imaging like the silency map and heat maps as well. What they are going to say, the abnormal kind of the things into the particular disease they are going to diagnose and going to tell us. The rule base, they can have to tell us what should be the decision according to that. And the question is arises, what need to change to alter the decision? This way, when we are going to use that, we have a particular, or we have the variety of the options. With the help of different methods, this disease is particularly diagnosed and detected. And on the basis of that, how much percentage we can have to improve in respect of the treatment. That's why these things are really helpful nowadays. This is all together what I'm going to use. And for that purpose, I have used one of my case study, that is the sepsis prediction. Sepsis is actually the infection. It can be responsible in the infection. It can be, you can find into old age people, diabetic people, you can find in the children as well. But mostly the diabetic, they have to be suffer because of that. And that is the life-threatening infection. The mostly patient, they are thinking just they are having an infection, but this is life-threatening. If life-threatening mean they can have to go to the ICU, they can have a high chances of the mortality, which they are going to consider very easy. But this is not that easy. And that's why I have taken this one as my case study. I have gone through that paper as well. And I have introduced some of the machine learning models in that to check how we can have to detect the sepsis in that. And for these kind of things, for the prediction, I have three different approaches, that is LM, Bayesian regulation, and SG segregate there as well. And when I have gone through all of three, I successfully during testing, I got the accuracy up to 99.7% in respect of this SCG. The rest of LM and Bayesian, they are giving around 92% as well. But this is one of the best approach, which is going to give the maximum, you can say, the accuracy, right? This is the proposed model, which is going to predict the sepsis disease. I have trained the model, and then I'm going to store and I'm going to predict that. And afterward, when I'm going to apply that, I have detected one of the SCG is going to give the required accuracy what I was expecting, right? This is the entire model which we have to be work for the sepsis. And this is the neural network approach which I have used, and on the basis of that, successfully I have done that. And overall, in graphical representation, if we can have to see over here, there is one, the LM training, LM testing, and this is the validation. It's entirely a bit less. If we can have to move on, BR, this is the BR training, testing, and validation is much better from that. When we arrived over here, SCG training for the ANN approach, it is comparatively to previous is much better. That's why we have considered this and this, both are slightly equivalent to each other, but still I have observed in respect to the testing, SCG more preferable. That's why I have selected as a final approach this one, but both are compatible. Now, when I have made this whole system, what is the risk scores, what the risk alert we will have to do, we are going to make some visual dashboard. In the dashboard, the doctor, the clinical person, they may have to see what are the risk for this disease particularly. They can have to work on their dashboard, and in the dashboard they can have to support the patients, and in the support they have to give them the antibiotics, the fluid management, the other oral medicines, and this way we can have to increase the confidence into the doctor, and we can have to reduce the chances of the mortality as well. And this way, I hope so it can work very well, because not only the implication of the AI work, along with that, we have a dashboard designing there to check their trajectory, to check how the clinicians, they are going to drive the particular thing, and it can helpful overall. These are the different devices which is going to diagnose different kind of things, different kind of tumors, different kind of screenings, different kind of analysis. I have particularly saying here the tumor detection, pneumonia screening, ECG analysis, and in that heat map, they can have to, we have explained already, they can have to go to the particular abnormal parts in a scan. ECG, they can have to give us a beat level explanation. When we are having any of the monitoring device, they can have to give us early digital alerts. Why it is helpful when we are going to attach that, because sepsis, when you are having, afterward we are having a dashboard. Afterward, if we are going to use the wearable devices, after sepsis, it can have to attack of any of your organ. We can have to get the readings, organs, regular basis. It's mean infection is not going to affect the particular organs. A lot of the cases I have studied, cardiac attack, they have a brain hemorrhage, infection has to affect on the particular parts. And if we can have to go through study, and for the particular parts, we have to work with the wearable devices, it can be further helpful. It's mean not only we have to stay on the AI, we have to make a whole ecosystem, how it may have to work and how it has to be successful. Obviously, when we are going to play around the patients, doctor, the ethics and regulations and the governance should be there. And you have to show the transparency. They can have to support the safety edits and the bias detection. If something is going to be wrong, because we patients are not over experiments, we can have to get the decisions on the basis of the data set, but we can't do the experiments because ethical parameters are there, right? We have to be important to get the consent, and we have to share the decision making with the doctor to somehow, and this way the government have some setup framework, and along with that, if we can have to work, it could be really very helpful for the mankind. Human AI collaboration. AI augments, not only replace. It can have to work along with the doctors. It's not we can say AI can have to do everything. Yes, AI-based machines we are having, but they can have to be operated by the doctor still, right? And because of that, we are going to get very meaningful opinions from the doctors, and on the basis of the opinion, we can have to move forward. And feedback from the doctor can refine and retrain the models as well. If they are saying, oh, your AI model is working like that, we can have to get the feedback, and according to that, maybe we can do in a better what we have done at the moment. And outcomes. It is safer, more personalized, and efficient care. The future direction, we have to integrate XAI and deep learning together. At the moment, into my sepsis, I have walked through the ANN models along with the AI. I further recommended I have to, for myself, to do with the XAI as well, and move on to the federated approach, because federated approach can help us to move around the weights and everything, rather than the actual data we have to be shared into the particular hospitals or particular organization. and particular government persons as well, because we don't need to breach some patients' information or data as well. That's why this way we can have to go for a formal evaluation of the trust, usability, and impact on outcome. This is all together, all my stuff, how we have to work on XAI along with the deep learning approach. And we are already having a trust, more for the research, more for the trust. If we can have to implement, we can do more better into this field, especially into the healthcare, which I have been selected. That is my use case. And trust is essential for AI adoption in the healthcare, because without trust, we can't move forward. Explainability turns the accurate model into the clinical, and SEPML model is which is going to give the higher, you can say, the accuracy or the output, and your collaboration. All of the researchers are really very important for me. If we can communicate with each other, we can have to discuss the ideas. Someone is working on this, I'm working on that. This way we can collaboratively do much better into particular fields. Thank you very much, everyone. If you have any question, do ask me.